This is R.d.sharma solution class 12th. We are taking exercise 19.25 of indefinite integrals. In this x cube tan inverse x dx, which will be the first function and which will be the second function, this is the first step we have to decide. We don't want this integration of tan inverse x to come. That's why we'll take this as the first function and x cube as the second function. I am applying the formula directly. It's tan inverse x integration of x cube minus integration of first differentiation of tan inverse x followed by the integration of x cube, and then after the combination or multiplication of these two we'll integrate it again. So tan inverse x integration of x cube will be x to the power 4 divided by 4 minus what is the differentiation of tan inverse x? It will be 1 by 1 plus x square, which is obvious, you already know that. X cube will be similar to what we have just done, x raised 4 by 4. Now we have to integrate it again in terms of dx. Now this first term is already been done, so we will deal with the second term, and that will be done separately. I'm going to show you separately. So I'm taking this 1 by 4 out for time being. I'm calling this as a and integrating it. So we are integrating x raised 4 divided by 1 plus x square in terms of dx. Now there are different types of approach you can apply. You can call it as x squared to the power square, and you can take 1 plus x square as t or x square as t, and then you can go forward. But there is a better solution that you can just add a 1 and subtract a 1. That is, you know a squared minus b squared is a plus b into a minus b. That formula is quite known to us. Let's use this formula here. So x raised 4 minus 1 divided by 1 plus x square. I'm separating these two terms. Plus 1 divided by 1 plus x square. Now this first numerator will become x square whole square minus 1 whole square. So it's basically a square minus b square, and we are employing that formula which I just intimated you. This will be x square minus 1 into x square plus 1 divided by 1 plus x square, and 1 by 1 plus x square is already there, and we'll integrate them now. But before that, you already know tan inverse x differentiation is 1 by 1 plus x square, so you already know what is going to come for the second term which we are doing. 1 plus x square I'm cancelling, so you just have to integrate x square minus 1. It's a very simple integration of x square minus integration of 1, which is in terms of dx, plus integration of 1 by 1 plus x square. Now dx is everywhere, you need to write that. This will be x cubed by 3, the first term. Second term will be simply x. The third term will be tan inverse x. Now we have a negative 1 by 4 in front, which I separated earlier. Now we need to multiply all of them with negative 1 by 4 and then combine it with the first term, which is tan inverse x into x raised 4 by 4. So I'm writing it right now. And this term will be actually not subtracted but actually multiplied by negative 1 by 4. So x cubed by 3 into negative 1 by 4 will be x cubed by 12 in negative. Negative x multiplied by negative 1 by 4 will be x by 4. And negative 1 by 4 into tan inverse x will be negative tan inverse x divided by 4. Now you can combine these two terms. Tan inverse x can be combined or it can be taken out. The inside thing will be x raised 4 minus 1 simply, because you already have this x raised 4 by 4 minus 1 by 4 if you take tan inverse x out. The better way is to take the 4 out, and you can just write x raised 4 minus 1. It's up to you. Now these two terms have been taken care. Now we are left with this x cubed by 12 plus x by 4. Now I'm taking x by 12 outside. You can take 1 by 12, you can take x by 12, it's up to you. So this will form 1 minus x square, 3x square actually, because this 12 was already taken, but 4 is there in the denominator of the second term. So 1 minus 3x square plus constant of integration. Now you can have a 4 here also. You cannot take this x, you can keep it inside. It's up to you. There are two ways of representing the final result. So this is the final result which you can follow. This reference is given to you. And this is a very straightforward question. And there is one more result which I showed you. This is the another result. X sin x cos 2x dx. Now you need to know one formula which I'm just going to write, and that will be very beneficial in order to make this question very simple. 2 cos A sin B is equivalent to or is equal to sin A plus B minus sine A minus B. Why I did write it? Because you have sine x and cos 2x together here. You don't have a 2, so we have to include a half that I'll show you later. So 2 cos 2x and sine x, I've just swapped the terms cos 2x and sine x. So this will be sine A plus B, that is sine 2x plus 3x. So let's write sine 2x plus x, and then will be sine 2x minus x. First term will be sine 3x. The second term will be sine x. You already have a x here. So now let me write the original question along with the formula which we just used. Sine 3x minus sine x is already there, multiplied by x. Now you already know what to do. Just multiply x with the internal terms. And as I was suggesting, this 2 was by our virtue, we got it. We actually placed it, so we need to have a half outside. That's why we have a half outside. But we will deal it later. We'll keep it in some temporary storage and we'll record it whenever it is required. So now first term will be x sine 3x. The second term will be x sine x. So x sine 3x and x sine x here. We will integrate it using the formula. I am taking the first term. X will be the first term in x sine 3x. Integration of sine 3x minus integration of d by dx of x, and then again that integration of sine 3x, and all these combine and integrating with dx. This is just for x sine 3x. Now I'm doing it for x sine x, the second term we have. X integration of sine x minus integration of differentiation of x followed by the integration of sine x again, and then the combined result will be integrated again. So the first gave you x, sine 3x is minus cos 3x, but 3x will be differentiated and 3 will be divided, minus d by dx of x will be 1. Integration of sine 3x will be again negative cos 3x by 3. So let me write it here so that we can directly write the result. So let me just do it somewhere else. Sine 3x will be negative cos 3x divided by 3. Then this has to be integrated again because it is again having an integration. So negative 1 by 3 if you take outside, cos 3x will be sine 3x, and this sine 3x also have a 3x, so you have to differentiate it and divide by 3. So final will be negative sine 3x by 9. But since we have a negative outside, it will be plus sine 3x by 9. Now this second term, we are dealing them separately and we'll combine them later. X, integration of sine x. What will be sine x? It will be negative cos x. Minus d by dx of x will be 1. Integration of sine x will be negative cos x. Negative cos x will be integrated again. So it will be sine x. So negative sine x will come. So negative x cos x, and since negative is already there, it will form plus sine x. So minus cos x plus sine x, and it is preceded by a negative because we are combining it now. But we have a half also. So let's multiply everything by half. This one also by half. And then we'll combine them. So negative x cos 3x, 3 and 2 will form 6. 3 into 2 is 6. And plus sine 3x, and 9 and 2 will form 18. This is negative x cos x divided by 2, but we have a negative sign preceding, so you have to make it as a positive. I'm changing it here only. So this term will be x cos 3x divided by 2. I have taken care of the sign now. Negative sine x divided by 2 plus constant of integration. This is your final result. So this is the reference for you. The main key of this question is this sine formula, tan inverse x square x into dx. Now if we are getting x tan inverse x, you already know how to do that. If you know x tan x, you already know how to do that because we are on the 51st question and we have done it already. So I'm taking t equals to x square, that will give you dt by dx as 2x. So dt by 2 corresponds to x dx now. You already have a x dx here. So let me just integrate and write the actual terms here with the transformation to t. So x dx will be dt by 2 and tan inverse x square will be tan inverse t. So this integration tan inverse t dt is quite known to you. How to go about it? You have to have a term which is 1. So assume or imagine tan inverse t into 1. So half will deal later. 1 into tan inverse t into dt. So first term will be what? It will be tan inverse t. We don't want integration of tan inverse t to come again and again. So we'll integrate 1 dx, 1 dt, integration of d by dt of tan inverse t, and then the integration of 1 dt again, and final we will integrate it again. So 1 dt will be t only, so t tan inverse t minus d by dt of tan inverse t will be 1 by 1 plus t square. Integration of dt will be t and then the dt. Now I am doing it separately. 1 plus t square will take as say some p. dp by dt will be equal to twice t. So dp by 2 will be t dt because we have t dt in the numerator. So we can replace it by dp by 2 now. dp here half goes in the front. 1 plus t square is p. So dp by p will be log modulus of p. Half log modulus of p. So half log p was taken as 1 plus t square. So let me write it here. T tan inverse t minus, as we have already exchanged p with 1 plus t square, so half log 1 plus t square will come. It will be negative half log 1 plus t square and then with a constant of integration. So plus c will write. The only thing remaining is the t was taken as x square earlier. Half has to be multiplied, so I am just multiplying everything by half, and then the final replacement of t as x square. So half x square tan inverse x square minus 1 by 4 log 1 plus t square is x square square, that is x to the power 4 plus constant of integration, and this is your final result. All right. So this is very straightforward because if you are following these 50 questions previously you discussed, this will be quite easier for you. So unless you know the previous formulas, it will be very difficult. Now we have x sin inverse x divided by under root 1 minus x square dx. So first thing is we want to get rid of this inverse, sin inverse x. For that we'll take x as sin x. That is the best way we can go about, or we can proceed. Let's take x equals to sin theta. So this sin inverse x will be theta. When we differentiate x equals to sin theta, dx by d theta will be equal to cos theta. So dx is equal to cos theta d theta. So the integration will be something like this. X will replace by sin theta. Sin inverse x has become theta. And under root 1 minus x square, because dx also is there. So dx can be written as cos theta d theta. So in place of dx I am writing cos theta d theta. Now denominator under root 1 minus x square, so 1 minus sin square theta. 1 minus sin square theta is cos square theta, and under root of cos square theta is cos theta. Please remember this because we are going to use it again. So this cos theta in the denominator. Now it has become so easy. Cos theta get cancelled. You just have theta sin theta d theta, and this has been done numerous times. Because x sin x, x cos x we have dealt already. So I am writing directly the result. Please understand, I am not integrating it. You already know that. I am writing the final result, which is negative cos theta plus sin theta plus constant of integration. Now replacement. Theta will be sin inverse x. Cos theta will be under root 1 minus sin square theta, but sin theta is x actually. So it will be under root 1 minus x square. So it can be written as under root 1 minus x square. So under root 1 minus x square. And then we have a sin theta. So plus, what will be sin theta? It will be x plus constant of integration. That is your final result. So this is your reference which you can follow. If you don't know how to do x sin theta or x cos theta, that is a reference for you. But I hope that you already know about that. Sin cube root x will be dealt later. Till then, thank you so much. Have a good one.